Today, see Tanium Threat Response in action with a real-world incident response expert. Welcome back to the Tanium Tech Talks. I'm your host, Ashley McGlone. You know, I've always wanted to feature real live customers on this show. And if you'd be interested, I'd love to have you join us. And today you'll get to meet someone who uses Tanium Threat Response in real life every day. It's what they do. And they are simulating now for you exactly what they see every day so that you can learn threat response in the real world and know what features to focus on. So he has the heart of a teacher, and he's a frequent speaker all over the security community here in the U.S., places like regional ISSA events, B-Sides Las Vegas, and many more. So help me welcome from an undisclosed location, your peer Tanium user, Matt, to the show today. Matt, tell us a little bit about yourself.
Thank you, everyone, and thanks for having me, Ashley. It's great to be here with Tanium today. It's a tool that I use daily in doing digital forensics and incident response. And as part of that role, we try to answer the who, what, where, why, when, and how questions when it comes to security incidents and investigations.
So Matt, why is Tanium your tool of choice for this?
What I love about Tanium is it has sort of that one-stop shop appeal to it. We are able to use it for a lot of things that would ordinarily take a wide array of tools and different processes and techniques. So that one-stop shop, or as close to it as we can get, is what's extremely helpful with Tanium.
You know, we frequently hear that security engineers have more work than they can handle. I hear that all the time. So how does Tanium specifically accelerate your investigation process?
It enables us to do what we do quicker and easier, and it has the information we need in one place so that we're able to be efficient in what we do.
Is there one particular feature in threat response that's I know you use all the things, right? But is there one particular that's your favorite go-to?
What I like about threat response is that we're able to connect to an endpoint and quickly and easily obtain files without having to jump through a ton of hoops to get there.
And so what do you have in the lab for us today? I'm eager to see what you're going to demo.
Sure. So if we take a look at Tanium at the home page, I can quickly take a look at my total endpoints here. This just gives us a quick overview of the demo environment. So I've got the host names, IP addresses, the operating systems, all at a quick glance, which is super helpful to have. If I go into the threat response module, and to be honest, that's where I spend most of my time, that and interact, which we'll also showcase a little bit here. If I go into threat response, I'm able to drill into alerts and see if I have alerts for particular hosts. You can see here, I have one specific endpoint of interest, and I've got multiple alerts from that endpoint. And we can see quickly at a glance here, the platforms, the paths, the intel name, and the MITRE attack mappings on that, plus file hashes, timestamps, those sort of details. So let's take a quick look at the first alert here at the bottom. And if I click on this, I can quickly get to the alert details, which is where I want to focus. And quick summary here gives me information about the system, pretty basic stuff. When I start going into the summary, or rather pivot to the platform information, tells me again about the system. The event information is really what I'm most interested in. And what we see here is what's happened. We have a process. We have the process name that executed. We have a process ID or a PID, which can be really useful when we're doing investigations. Again, we have our timestamp, and we have the user context in which the process executed under. And what's extremely helpful here is the command line. I can see in this instance, net sh firewall, set op mode, mode equals disable, profile equals all, tells me as an incident responder that somebody has just disabled the Windows firewall across all profiles. If I see that in the real world, and if I'm depending on Microsoft Windows Firewall, for example, as my host intrusion detection or prevention system, to see that disabled is definitely a little concerning. And if I go into process ancestry here, getting close to the bottom, I see from PowerShell, it's running. We see that it's executing a command.exe, and what we have from there is executing this dwfw.cmd. And what's nice about Tanium is it actually tells us what was executed from within that command that triggered the alert. In this case, it's that command that we looked at, and it's telling us to disable the firewall. And what's cool is I can then pivot into the MITRE attack frameworks and see different things here. So impaired defenses, and really this particular MITRE mapping, impaired defenses, disable or modify system firewall. It's exactly what's happened here. And in this case, this is why I would be concerned about it. Now you may see normal processes, for example, will have things that map out to MITRE, but the more things you see in here, it's just a better indicator that it's something malicious. If I go from here into the next alert, we have very similar to what we saw before. If I come back into the event information, what we see here is the net.exe command is executing, and it is essentially querying domain admins from the domain controller. So that's an enumeration technique. And when I start looking at the process ancestry here, things get quickly concerning. So for example, when I'm looking at PowerShell running, and when I see the execution policy bypass switch here, that's essentially overriding the default policy, which for example might require that script be a signed script. And so this will execute anything. And what's really helpful here is I have the actual command. I can just click on here. You'll see that it actually copies that whole thing to the clipboard. It doesn't tell me where it happened from, but I see the actual PowerShell script that ran. Going a little further into the process ancestry, we can see this is an encoded command. Typically, that's going to be in base 64. You see a lot of that in PowerShell. And the reason a threat actor might leverage that would be to evade detection. So what I can tell is happening is it's executing the net.exe command. And we can see here, again, that command line we just looked at where it's querying domain admins.
Really curious. You see this stuff every day, and you just covered only 2 alerts so far. Are there trends that you notice, and what particular alerts or attacks are most common that you see?
We see some of everything. And one of the more recent trends is what's called LOLBAS, which is living off the land binaries and scripts. And when we see things like PowerShell, well, PowerShell is on virtually every Windows endpoint there is. That's why threat actors will often leverage PowerShell because it's already on the system. In other words, they don't have to deploy, for example, a malware platform on the environment. One sort of exists. And PowerShell, it's sort of an amoral thing, right? It could be used or misused depending on who's using it for what purposes, either good or malicious, much in the way somebody could use a hammer, for example. So this is very common to see in modern day attacks with threat actors leveraging those built-in binaries and scripts that live on an endpoint.
Yeah, I'm glad you brought that up because I've campaigned for years about not removing PowerShell from the environment as a knee-jerk reaction, because when you do that, okay, you're tying your hands behind the back when it comes to trying to do regular administration in the world of Windows. So now that we've got some details here on some malicious activity, how do I take this to the next step?
So when we look at this command, we have a specific PowerShell script file. What it doesn't actually tell me on this screen is where that executed from. So that's typically where I'd want to understand why this happened. Where did it happen from? Now we know the endpoint based on the alert summary. We know the user context it executed under, but again, we just don't know where that lives on the endpoint. I had copied that script to the clipboard. So if I copy that specific PowerShell script, I can then come into essentially the threat response module and go into a live endpoints connection. To get there, I can actually just click on the link here to start the live connection to the endpoint I'm interested in investigating. And so if I come in here and I come into the File tab, again, I know the PowerShell script I'm looking for. So what I can do with this is I can come in and search on the path contains, and I can literally paste in the name of the script I know I'm looking for. Now, what this actually tells me is where this file exists. So we see it's under the user's downloads folder. What's also interesting here is it shows me that it was obtained through Microsoft Edge. As a forensic investigator, and we'll talk about this later, I can actually obtain the browser history file using Tanium and use a SQLite database browser to understand what the history is, and that would be further evidence I can collect using Tanium from that particular endpoint. The important thing to understand as well is Tanium, as good as it is at capturing alerts, and this is something detection engineers or people can write their own signals to detect really whatever they want, and you can make those as simple or as complex as possible. You have to sort of balance that, getting too many false positives versus this is the kind of malicious activity I want to detect. So the real question is, are there other things this script does, for example, that we don't know about? Now that I know which user it is, it's in their downloads folder. What's really cool that I have this live endpoints connection, establish your Tanium, is I can browse the file system and I can go into the users folder. I can go into the particular user of interest, go into their downloads folder. I see all the contents of this folder here, and lo and behold, here's the PowerShell file I'm actually interested in. And what's great about Tanium here is I can click on that and it's going to prompt me to save it to saved evidence. So I can go ahead and confirm that and say, yes, I want to obtain that. And that's going to go into saved evidence. So let me go ahead. I don't want to close this window, but let me go ahead into saved evidence. And now I see the file here in saved evidence. If I don't want to look at, for example, snapshots that may have been captured, I can go to File, and that's going to help filter down that list for me. And what's really cool is I can expand this and review the details. So I can actually see a timestamp of when it was downloaded. I actually have a hash value of that particular file. That's something I could query using an engine, maybe like a VirusTotal or some other solution like that, to understand what it is. Again, I have all the timestamps from creation to modified time, the full path, and the user that has requested the file be saved into saved evidence. It's important to know that as a team of investigators, other people that saved things in Tanium and want a second opinion, I can actually hop in. I don't have to re-download the file. It's there waiting for me, so I can actually go in and be that second set of eyes for somebody as an experienced incident responder. So I'm going to go ahead and just download this file. And from here, Tanium doesn't want you to get infected, obviously. So rather than just giving you a potentially malicious script, it's in a password protected zip file. I'm going to go ahead and extract that and extract it out to here. Usually when you're looking at malware samples, the default password is either going to be infected or malware. Those are by far and away the two most common. So I'm going to guess infected, and sure enough, it was. So now if I come back into the downloads folder, open this with a better tool for reviewing this kind of information, now I can actually see the code looking a little better. And you'll notice we have multiple encoded commands here. Now we could manually decode those to understand exactly what each line does, not just what triggered the alert. But what I want to focus on is we see a pipe and we have an out file path. And what's interesting here, now that I'm looking at these scripts that I obtained through Tanium saved evidence, is I can see it's outputting to a file. And so the string home environment variable is the user's home directory. And we have a directory in there called secret web app. Well, that's interesting. And we have a file 1337.txt in there. And each line is actually outputting to that particular path. Now, in the real world, a threat actor may have included that inside the coded command, but for illustrative purposes here, I think that's particularly interesting. So while I'm already connected to the system, I can sort of repeat that process in a similar fashion to browse to that particular location for the user. So if I go back to the user folder, and I'm going to go ahead and look for that secret web app folder and see if I can find it. And here it is. And again, because we were able to use Tanium to obtain the file, we actually see this text file. And if you remember, it looked like it was querying domain administrator accounts. That was what triggered the alert. Let's go into saved evidence again. And I'm going to, again, just repeat a similar process here, download it. We'll take a quick look at it and see what's in here. Here's my new folder. Just going to extract it.
I'll never forget the first time I saw live file browsing in Tanium, and I was just blown away because it works cross-platform too. That's one of my favorite features.
Yes, it absolutely does. No question about it. Now this, if I want to open it up in Notepad, I start seeing all sorts of information. So I've got the computer name, the domain it's joined to, all sorts of details about the IP address of the system, the gateway, the DNS server. I've got a list of the local accounts for the system, and I've got a list of privileges that are set on the system here. So all very interesting to a prospective threat actor. You'll notice here's all the Active Directory accounts in this particular domain. And here is, again, what really triggered the alert and got us interested is a list of domain administrator accounts. Now, if you recall earlier, we were looking at where the Windows firewall was disabled. So if the Windows firewall is disabled and we have information in the secret web app folder, if this person had, for example, set up like a port forward in their network devices, they could route web traffic here. What easier way to exfiltrate data and sensitive information than essentially enabling a secret web application and having, able to retrieve it remotely from anywhere. And this is literally data, that's sensitive information, secrets, if you will, walking right through the front door.
And so it looks like this is more the law bin or law bast, the living off the land binaries and scripts there, where they're just using native commands to get all that.
Yes, absolutely. And so that is, sort of at that point, we get really concerned with what's happened here. So what I can do is I can actually check the endpoint back here on the alerts tab. You can also do this a few other places, but for illustrative purposes, I've already seen enough that I'm really concerned about this endpoint. And if I, think there hasn't been lateral movement yet, since we're jumping in the alert fairly soon, I can come into actions and I can quarantine this particular host. So that will isolate it from the rest of the network environment. And that's something we absolutely do when we have an endpoint that we're investigating. And when you've seen enough concerning things that you feel like you need a deeper dive, but you need to isolate the system before there can be lateral movement, before there can be persistence established. Again, we would quarantine this endpoint so that it can no longer talk to things outside of, for example, the Tanium servers, maybe a few other options that we would choose within our environment. For example, other security tools, those sort of things for purposes of deep dive forensics. The other thing I can do here after I've got the host quarantine is a live response. I have different collectors here. I can get standard collection, which gives me a quick overview of host details. The extended collection, which would give me a lot of details about the host that I've just quarantined. I can also do a memory collection to obtain a memory dump. And from there, I can either use a commercial forensics tool or an open source solution to do that memory dump analysis. And in this case, I can store it locally. If I've got Tanium configured, I could store it to a specific network share. And again, that would be something that would be excluded from quarantine, those sort of things. So this is really what helps me next level.
Hey, so right there on that live response, I just want to make a quick commercial here for using it, because I know I've set this up with some customers in the past, but I know I've got customers who still don't have it set up yet. This is hugely valuable. And so it gives you a way to set up a depository on your network where you can receive these files in a central analysis point where everybody in the team has access to go in and review those. And you can set up the permissions to keep it secure in the environment.
And the other thing is sometimes you have an alert that comes from outside of Tanium. For example, you might have something monitoring for phishing, and sometimes those things will give you retroactive alerts. You might have something in your SIM tool that tells you there's something concerning. We can absolutely use Tanium to hunt for that from an incident response perspective and respond to additional alerts. And just do a quick demo. Let's pretend that there is a concern for a file called badware.exe. Let's say maybe it's a phishing campaign and it's been blasted across the entire enterprise, and we want to understand, did that land on any particular systems? So let's go ahead and investigate that using Tanium here. And if I go back into Interact, that lets me do this. And so I can actually run a query here to get the computer name, index, file details. I see it here. Now I can just click on parameters, and that kind of takes me to sort of a simplified version of build question. And again, all I have to go on in this environment is the file name. That's all I know, is I'm interested in trying to find badware.exe, and does that exist in the environment? And if I hit enter, it'll ask the question right away. I can also add additional things to this query and ask a question. But in this case, I just want to know across the entire enterprise, because I don't know what endpoints may or may not have seen this particular file. So I'm going to go ahead and run it. And we see Tanium running here. It's about halfway through. It has actually found our, again, our workstation of concern. And sure enough, we actually have this particular file found. We get a lot of great details here. What's really cool is it'll give us the directory path. Again, we could copy that to the clipboard. We can expand these columns a little bit to see that a little further, whatever we want to do here. We see the file name. And what's really cool with Tanium here is it gives us a hash value. Now, depending on how these sensors are configured, you may have more than MD5. You could get the SHA-1, SHA-256, all the way up to 512. Looks like in this environment, we're just configured for MD5, but really for most forensic investigations, that's kind of all we need. What's really cool that Tanium added is this thing called the magic number. So these things are magic numbers, or sometimes they're called magic bytes. Sometimes they're called file headers. It goes by many different names, but it all really means the same thing. And what that is, for those who aren't familiar with that term, or that this conceptually, is that applications need to know what a file type is to know if they can process them or not. And so what happens is typically about in the first 4 bytes usually, and that's mostly what I'm interested in, files sort of identify what they are, because it's important to remember when you're investigating things that file extensions, they can be renamed, they could be removed. Those things are all possible. And so what we see here is we have 4D5A is our first 4 bytes. A reference I use often is Gary Kessler's really awesome chart here for finding these file headers. So if I do a Control F and I do the 4D5A, it's going to find this particular byte, this magic byte, magic number, file signature, again, goes by many names. If I was looking at the ASCII output table at the, of a particular file, it would give me MZ, which interestingly enough is named after the person at Microsoft, this Mark Zybkowski, that created the exe file format. But the important takeaway here is that this tells me ultimately that it's an executable file. And of course, executable files are always somewhat concerning. And what's really cool is it's going to have this magic number, even if it said badware.exe.pdf or something like that. It could have any extension. The magic byte is really that source of truth as to really what sort of file type it actually is on the environment. So that's really cool to have. And again, it gives us the hash value. So what's nice about this, and again, in our table of endpoints, we only found this one place. But again, threat actors, malicious insiders, those insider threat situations, they can be a little sneaky, right? So I can actually copy the MD5 hash value to figure out, does this file exist perhaps under a different name on an endpoint? And so I've copied this to the clipboard. Let me come back in here to the parameters, and I'm just going to wildcard the file name again and paste the value into the MD5 hash. And again, if I enter, it's going to run this query from all systems. This is where things start getting interesting, because we actually see the same endpoint found again. However, we actually see, once this query is done running, we've got multiple instances of this particular file. And when we look at this, we see that there's a version of this file under app data local called goodware.exe. So it's important to remember that if an antivirus engine or even your own Tanium signal match is looking specifically for a file name, it wouldn't find goodware.exe if all you're looking for is badware.exe. So that's why querying hash values is important, because it gives us the forensic values regardless of what the particular file is called. And so that is super powerful.
So Matt, I tell you, when you talk about forensics, all right, this just reminds me of forensics in the real world with the black light, finding things you can't normally see, looking at magic numbers, looking at hashes. You've got visibility here that gives you the ability to see where this is really happening and what's the extent of it.
Correct. And not only that, it also shows us where across the entire environment that particular file might live. So we could figure out really what was the exposure. Just because we found it on one endpoint doesn't mean it doesn't live on additional endpoints. All right, so in here we've found our file by essentially querying for the hash across all of our endpoints. And we see a couple of things. We see it in the browser cache folder. We see the badware.exe version in the downloads folder, and we see it renamed as goodware.exe inside of an unusual location, which is the C users C Gibson app data local folder. And that really is a sign that somebody's probably trying to hide something. Don't be thrown off by the funny name in the browser cache folder. That's sort of an ephemeral name that cache files acquire when they're downloaded from web browsers. So from here, what we're going to do is answer the question, was the file actually executed or not? And that's a very important thing to figure out, because if it's just if it's a malicious file but hasn't been executed and it's just benign sitting there, it's less of a problem than if we believe it's malicious and it's actually been executed. So what we're going to do is we're going to go back to our alerts. There's a number of places you can do this, but you can simply click on the endpoint to start a live connection to that particular host. So now we're connecting to our endpoint of interest. All of our alerts have the same name, so we know we're in the right system. And what we're going to do to figure this out and answer the question, was the payload executed or was it not? We're going to add some filters, and I'm going to look on command line contains. And the two file names that we had were badware.exe, and I'm going to throw another command line in here, contains, and I'm going to search for it as goodware.exe. The reason I'm not getting anything is the filter. You always have to be very careful on this. Make sure that you're using the OR connector, so either thing matches. And since we see the process path here in the command line, we know that badware.exe wasn't executed, but by all appearances, after the file was moved and named as goodware.exe, we now know that this particular file has executed. And so at this point, we're going to, if we haven't already quarantined the box, this would be a good reason to do so if we've looked into this particular file and determined that it is in fact bad. And of course, we could actually use Tanium to retrieve that file, do our analysis. Forensically, the hash values match, so it doesn't really matter which file we get. They're both the same, but that's essentially how we can take a look, determine was it run on the endpoint or was it just downloaded but not executed.
So I see you're in the process type of the type of data there. And if we click that little crosshair reticule on the left of that goodware exe, I'm curious to see what comes up in the process explorer. What happened? Was there anything else that it did?
So yeah, it's sort of interesting when you look at this. We get the timestamps of the event, and you can see there's not much time. So it was a fairly quick execution. That could be crucial if something's continued to run for a long time, but it doesn't mean, it doesn't mean nothing malicious happened. In fact, you see a lot of multi-stage malware where you might see a short runtime for one file, but it's getting other malware, and that stuff is running. One thing you can kind of get a sense on is, what happened after goodware.exe was run, and we do actually see this command exe in here, and we can actually take a look at that and see that it did actually execute a shell command, and chances are that this badware.cmd is actually embedded inside of our goodware.exe file. And again, this is a file that we could have obtained to look at, but it gives us a lot of good information in here. We're able to look at parent and child processes in the window and understand a little better what's happened. We can also take a look to see if there were any registry actions, file actions, network actions. Image can give you a lot of interesting stuff. It can also be a bit of a black hole, so to speak, because anything that executes and touches any DLL file, as you see here, or any other executable file, is going to show up in that list. If there's drivers involved, we would see that here, DNS traffic, and you can also take the combined view and just sort of see all of the artifacts around this. And of course, cmd.exe, just like PowerShell.exe, is actually a sub-process of the conhost executable file. So yes, you can actually learn a lot of interesting stuff as we drill into the details here.
You've walked us through a couple really good scenarios here, using that magic number, using the hash, using the live response, the live endpoint, and the live file browsing. It looks like you've used a lot of the capabilities of threat response. What else would you recommend to folks who perhaps maybe they've been using threat response for a while and you think, hey, don't forget about this feature, or maybe they're new to threat response? What would you want to make sure that they understand? I
think just really, if you want to get good at anything, it's a matter of spending time in the seat and sort of looking around for things. I'm not recommending that you purposely do things in your production environment for the purposes of throwing alerts, but really have a look at all kinds of alerts, even things that might be filtered out, things that get tuned out in your detection rules. There's nothing wrong with going into threat response and going into alerts, and maybe even things that have been noted. Go back to the main window. You can see the filter right now is on status unresolved. You can remove that filter easily and start seeing things that are, perhaps a different status, things that have already been resolved, drill into, and really just kind of read through the alerts to understand what they are, and then sort of ask yourself, how do I find these particular things of interest using Tanium Threat Response? So really it's just sort of a matter of going through the processes, learning the tool, leveraging your help files, obviously, but really the more time you have in the seat, the more you get comfortable with using the tool, the more you're able to use and leverage a lot of its capabilities.
Matt, thank you for giving us this tour of a real world look at threat response. Obviously, this is anything but the real world in this lab environment. And I know I've been watching you struggle a little bit with the remote connection in the lab. So apologies to our viewers. It's not the best example of a Tanium console experience, obviously, with a big screen and tons of resolution, but you get the idea. So, Matt, I also know that you're really active in the security community. I was hoping you could just kind of take us out here and talk a little bit about what it means really to participate in the security community.
So the community has really done a lot. I'm very blessed, if you will, and fortunate to have a great career working in information security. It's really sort of a dream come true for me from, well, a long time ago, honestly. And I've always wanted to give back. And I remember trying to break into the industry, trying to learn things. It was really hard to find a mentor. So I have spent a lot of time trying to give back to the community. And I've done things like I've created training workshops. I've gone to conferences all over the country to talk about information security and really give people hands-on, tangible things they can take back with them. A lot of technical knowledge and know-how, and examples and places, things they can do to get that first-hand knowledge, sort of that hands-on keyboard and time in the seat sort of knowledge, really to help them in their own career paths and sort of make everybody better. We, as security professionals, have big challenges with threat actors coming at us all the time. That if you have an internet presence, you're under attack all day, every day. They win too many times. It's all over the news with places getting compromised and so forth. And even if the breach isn't prevented, the quicker we can respond to those things, the more we can minimize the damage or sort of quickly understand what's happened. So then we can take those actions to prevent those things from happening in the future. And I really like information sharing about those sort of topics because that helps other organizations not fall into the same traps and pitfalls. So those are some of the reasons I like to give back to the community, and I'm as involved as I am.
You're right. It really is about paying it forward because, how every day we're always looking for, there's something that we've not seen before, but somebody else has, and we can look that up. We can see a session at a conference. We can read a blog post. We can read it on social media. So Matt, thank you for what you do to make the security community a better place and to pay it forward as so many other people. You benefited from what they contributed, and now you're contributing. And that's really a model I want our viewers to understand is, there are people out there who are providing content in the community, and here's an opportunity for you to look around at all the different places you can engage in security conversations online and begin to contribute to that. So I hope you'll consider that. So Matt, thank you again for joining us here on Tanium Tech Talks today. And so folks, Matt shared some resources as he went along. Down in the show notes below, you'll see a link to that magic number website. That was really handy. And also, of course, the Tanium Threat Response docs and community and all kinds of helpful links for you as you get started or even continue to go deeper in your experience with threat response. So that's our tour today of threat response in the real world. And until next time, Go-Tanium.
This is fun. Thanks for having me.